Hi Year 12 Maths General students. This lesson is looking at the effective interest rate, and the objectives today are to explain the purpose of the effective interest rate, to calculate the effective interest rate from the nominal interest rate. We're given a nice little formula to use there, and then once we've done that, can we use the effective interest rate to compare loan or investment options to help decide which the better option would be? Okay, so far we've looked at compound interest recursion methods to compare loan and investment opportunities to see which is the better deal. However, as you've seen, that's quite a tedious process and it takes a long time. And we can use another feature of financial maths known as the effective interest rate as another way to compare options. So essentially, the effective interest rate takes into consideration that compounding power, so your K value of loans or investments. So the more times it compounds, the more interest you accrue. And this is a way of expressing any nominal or stated interest rate as if it were compounding once a year. So it's like a conversion of the nominal interest rate. To help explain how effective interest rate works, we're going to look at an investment of $6,000 taken over a period of 1 year at a nominal interest rate or stated rate of 5.2% per annum. And we're going to compare the differences annually, quarterly, and monthly over the period of that year. So if we have a look at the yearly balance, you can see just at the end of the year there, it gets compounded once. So the balance after 1 year is $6,312, which means that it earned $312 interest. Compare that to if it was compounded quarterly, you can see that it gets compounded 4 times a year. And at the end of the year, it has a balance of $6,318.14, which you can see that accrues $318.14 worth of interest. Lastly, compounding monthly, you can see every month we've got interest being applied 12 times over the period of the year. So the balance at the end is $6,319.54, giving us $319.54 worth of interest. Okay, so let's look at how the effective annual rate interest rate is calculated if we know the interest earned. So you'll notice for the investment that was compounded annually, we took the amount of interest, put it over the $6,000 principal, and the effective annual interest rate is the same as the nominal interest rate because they're both compounded once over the year. If we move on to the quarterly compounded investment, if we take the $318 that was accrued over the year, we put that over the $6,000 and convert it to a percentage rate, we get 5.3% per annum. So effectively, that's like charging a nominal interest rate that was compounded once over the year to give us that effective annual rate of 5.3% per annum. And then lastly, if we look at the compounding monthly, we see that it accrues $319.54 over the period of the year. Put that over the 6,000, convert it to a percentage, and that's effectively like charging a nominal rate of 5.33% per annum that was compounded once. So you can see that the effective annual interest rate is like converting it into a nominal compounded annually once a year. Okay, so why do we use an effective interest rate? Well, it has implications where if we're taking out a loan, we're looking for a loan with a lower effective interest rate, so we'll pay less interest. If we're making an investment, we're looking for a higher effective interest rate, so obviously that will accrue more interest over the period of the investment. So it's a very handy and simple way to compare options that you might have for a loan or an investment. Okay, so if we know the effective interest rate is equivalent to a nominal interest rate with one annual compound, that gives us the same amount of interest over the course of 1 year, it's really easy to calculate the effective interest rate if we're just given the normal interest rate as well as the number of compounding periods per year. And luckily for you guys, on your formula sheet, you have that formula to calculate an effective annual rate of interest. So the way it's written, to find your effective interest rate, it's 1 plus your decimal nominal interest rate divided by the number of compounding periods per 1 year, and then put that to the power of the number of compounding periods per year, and then you minus 1. Now the answer you get will be in decimal form, so you have to times it by 100% to put it back into percentage form. So for me, I personally would find this form of the equation a little bit easier to use. So because you don't get your nominal interest rate in decimal form, I like to have the divide by 100. Because I'm used to using the number of compounding periods as K, I just like using it that way. And then finally, after I've minus my 1, I remind myself that I need to times it by 100%. Okay, so I'm going to go through one example just to show you how to use the formula. And then, so in question 1, I'll do part A. You'll press pause and do part B yourself, and then we'll move on to other examples. Okay, so again, when I get to the question, I would always highlight important information by annotating it from the question. So we want to know our I, and we also want to know our K value. So I would always identify them to myself in the question itself. Again, I would write down my facts, and then all it's going to be a matter of is substituting the information that I have into my formula. Okay, so the one I'm using is my modded version. So 1 plus our I value over 100 by our K value, which is 12, to the power of 12. Then I'll minus 1, and then I'll times the whole thing by 100%. So I've got that effective annual interest rate in percentages. Okay, so again, be really careful with your calculator. So I kind of work out the middle brackets first. So 3.2 divided by the 100 by my 12. Okay, I'm going to put that to the power of 12. Minus 1 and times 100%. Okay, so that gives me an effective interest rate of 3.25%. So essentially, if that bank loan was compounded once a year, it would be compounded at a rate of 3.25%. Okay, have a go at B yourself, and we'll check in with your answer. Okay, so that's how you should have subbed it into your formula. Just showing you again how I would input it into my calculator. So put that to the power of 26. Take 1 times 100%. So that's effectively 4.91%. so compounded annually. Okay, the next two questions demonstrate how this can be used to compare options that you might have between loans or investments. So thinking about what we said before, for a loan situation, you want an effective interest rate that's like a lower one. So what you're looking at in option A and option B, which effective interest rate is the lowest? Okay, and question 2 is written in a simple familiar format where the question's kind of stepping you through what you need to do. Question 3, I've worded it so it's in a complex familiar format where you've got to decide what steps you'll take to show which investment that Ronnie has to choose if she wants to maximize her investment. Okay, so go ahead and have a go at question 2 and 3, and I'll check in with you after you finish pressing pause, and we'll see how you went. Okay, how did you go? For option A, I found that she'd be offered an effective interest rate of 6.14% per annum. Option B, I found an effective interest rate of 6.13% per annum. So because it's a loan, to answer part 2, she would be best taking loan option B with the lower effective interest rate. So she would pay less interest over time. For question 3, it's exactly the same process, you're just not stepped through it. So you need to think, well, I have to compare the two options in terms of their effective interest rates. So if we calculate for option 1, we have an effective interest rate of 6.23% per annum. For option 2, we have 6.27% per annum. So because Ronnie is after an investment, because option 2 has the higher effective interest rate, that means that her investment will get more interest over time. So option 2 would be the recommendation for question 3. All right, year 12. So the take-home messages with effective interest rate are essentially effective interest rates equivalent to a nominal interest rate with one annual compound, where you're generating the same amount of interest over the course of 1 year. We've covered how to calculate that by using the formula, and we can use that to compare options for loans or investments. So if it's a loan, we're looking for the lower effective interest rate. If it's an investment, we're looking for the higher effective interest rate.